I'm going to discuss about the concept of stoichiometry. In this case 1. Case 1 equation is taken 2a plus 3b is raised to 4c plus 3d. At time t equal to 0, 5 moles of A is given, 4 moles of B is given. Initially C is 0 moles and D is 0 moles. After time 5 seconds, then from A some amount is reacted, that is 2x. You can just consider 5 minus 2x and 4 minus 3x, and formed C is 4x and formed D is 3 by 2x. Next, dissociation moles. Here x is what? Number of moles dissociated. Similar to that, other equation I am going to discuss. 3 by 2a plus 4b gives rise to 3c plus 1 by 4d. Initially, at time t equal to 0, moles of A is 3 moles, moles of B is 4 moles, and C is 0 moles and D is 0 moles. After time 10 seconds, then left A moles is, what are the left A moles? Means 3 minus 3 by 2x and 4 minus 4x and 3x and 1 by 4x. Now in this case, other question I am going to discuss. 3a plus 7 by 2b gives rise to 3a plus 7 by 2b gives rise to 4c plus 5d. In this case, at t equal to 0, A is 7 moles, B is 8 moles, and after time 8 seconds, the A left is 7 minus 3x and B left is 8 minus 7 by 2x, and formed C is 4x, formed D is 5x. I am going to discuss about the case 2, calculation of volume of dissociated moles. In this case, example 2a plus 3b gives rise to 1c plus of d. At time t equal to 0, it is 5 moles of A, 6 moles of B, and C is 0 moles and D is 0 moles. Suppose 40% of B is dissociated. Here formula is Nx equal to A alpha minus degree of dissociation. Here N is what? Stoichiometric coefficient, and X is dissociated moles. A alpha. A is given moles of the compound, alpha is degree of dissociation and it is degree of dissociation. A alpha is degree of dissociation. Now at t equal to 0, initial moles, that is initial moles, and 3x equal to, after some time t, 3x equal to what? T equal to 0, initial moles is taken. After some time t, dissociated. After some time t, dissociated amount is what? 3x. Means it is after what? Some time t is equal to, we can take 15 seconds. Dissociated amount of B. How can you write? 3x. 6 minus 3x left. 3x equal to 40% of 6 moles. So x equal to 12 by 15. This is 0.8. So dissociated moles is 0.8. Okay. Next. Here after t equal to 15, if x equal to 0.8, then the values of the reactants and products, number of moles. So 5 minus 2x, 5 minus 2 into 0.8, and 6 minus 3x, 6 minus 3 into 0.8, x, so 0.8, 1 by 2, x means 0.8 by 2, other example, here 3a plus 2b gives rise to 4c plus 5d. 6 moles of a is given, 5 moles of b is given, and it is the 20% dissociated. Suppose nx equal to a alpha, then nx, n is what for a I am going to find, so n is coefficient, so 3x equal to 6 into 20%, then x equal to what now, 0.4. Then after 5 seconds, okay, amount of a is 6 minus 3x, and amount of b is 5 minus 2x, and okay, and the other values, what your 4c, c is 4 into 0.4, d is what your 5 into 0.4. Next, case 3, calculation of degree of dissociation. Calculation of degree of dissociation, if it is not given, then 6a plus 4b gives rise to c plus d. In this case, t equal to 0. Given moles of A is 2 moles, given moles of B is 4 moles. Okay, 0, 0. Then step 1 is to find limiting reagent. So given moles, limiting reagent for A. So that is given moles by stoichiometric coefficient. Now given moles is 2 by 6, 1 by 3. Next, limiting reagent for B. Given moles B. So given moles is 4 by 4. So 1. When limiting reagent of a compound is in least ratio, then the formula used for that compound is step 2, nx equal to a alpha 6x. Tapo. Okay, 6x equal to a alpha 6x equal to a alpha. A is what here? 2 into, okay, alpha. How can you take? Alpha is 100%. You need to consider. So 6x equal to 2 into 100. So x equal to 100 by 6. Then 33 is the answer. X is 33%. So here what degree of dissociation is not given, needs to consider alpha is 100%. Then you can discuss based on the what here, least ratio. Least ratio moles what here, A. Okay, least ratio 1 by 3, that is less value than P related to 1. So least ratio related to moles is given 2. So that only you can consider here, and you can get out. Next, if the degree of dissociation is not given, then consider 100%. Okay, then you are going to find number of moles of A, B, C, D. So see again one more example. 6a plus 4b gives c plus d. Then 2 minus, it is 6x, and 4 minus 4x, 0 moles, 0 moles. Then 2 minus 6 into 33.3, 4 minus 4 into 33.3, 31. Next, other example, a plus b. Other example is a plus b gives c plus d. In this case given 4 moles and 5 moles. Then limiting reagent for A. How can you take 4 by 1? That is 4. Then 5 by 1. Moles is 1. So 5. Then nx equal to a alpha less is 4. So n is 1. Okay. N is 1. And x is needs to find. Then 4, how it came? 4 is the least. Okay, least. So 4 moles given. Then 100. So x is what here? 4. Then other equation, 4a plus 3b gives rise to 4c plus 3 by 2d. T equal to 0 is 4 moles, 5 moles, 0, 0. Then after some time, T moles of A equal to moles of C. This is another model. Then 4 minus 4x, 5 minus 3x, 4x, 3 by 2x. Now remaining atoms of the compound A. Okay, 4 minus 4x equal to 4x, and 5 means they are equal already. So x equal to 4 by 8. If you got the x, then you can find the all values. 4 minus 4. Remaining atoms of A equal to 2 into Na, that is equal to 2 into 6.0 so 12 1.2 into 10 power 24. Next, calculation of equivalent weight. It is a very important concept. Now we will discuss these all topics. What I am going to discuss are very important for the NEET, IIT and some other exams what are going to write after 12, that is NDA, FMC, who are belong to the science group, and these are very basics to develop the chemistry. So please subscribe this channel and okay, go through the concepts. However, we have the dots you can send through charting. Then acidic species. In this case, acidic species means HCl, H2SO4, H3PO4, H3PO3, H3PO2. These like in this case you are going to find equivalent weight. So first you need to know the valency factor. Sometimes direct will ask the valency factor of the given compound. For this, replaceable number of H plus ions. HCl is H plus, H2SO4 2H plus, so valence factor 2, H3PO4 3H plus PO4 3 minus, so 3, H3PO3 2H plus, HPO3 minus, so 2. This way H3PO2 is H plus H2PO4 PO2 minus 1. In this case valence factor is 2, but here H3PO4 you can get direct. How that structure base P double bond OH. So it have the 3 OHs. But where is the difference? H3PO3 valence factor is 2, but here H is 3. Then where is it? Okay, difference with other compounds. For this needs to write the structure. POH double bond OH. This case here OHs how many? 2 H's. So that related H is only acidic H plus ions. Next, equivalent weight. Now the concept of equivalent weight. Equal to molecular weight by valency factor. Okay, molecular weight by valency factor. Molecular weight is 36.5 and valency factor HCl already found 1. So equivalent weight of H2SO4 98 by valency factor 2, H3PO4 98 by 3, H3PO3 82 by 2 41, and H3PO2 66 by 166. Now equivalent weight for the bases, so NaOH. In this case number of OH minus ions comes under valency factor. So here valence factor of NaOH is 1, valence factor of COH twice is 2, valence factor of AlOH thrice is 3, valence factor of MnOH 7 is the 7. So equivalent weight of NaOH is 40 by 1, that is 40. Next topic, salts. Equivalent weights of salts. In this case, number of OH minus ions, H plus ions involved comes. So see here, valency factor of NaCl reacts with H2O, NaOH plus HCl. Now in this case, how many H plus ions involved? 1. Then OH minus involved 1. So valency factor is 1. Same CaSO4 plus H2O. Now you will get according to balancing CaOH twice H2SO4. So in this case H plus ions are involved 2. See AlPO4 H2O, AlOH twice H3PO4, Ca3PO4 twice H2O, CaOH twice H3PO4. So in this case number of H's, okay, Here valence factor is 1, valence factor is 2, valence factor is 3. Here valence factor number of H plus. Okay, valence factor valence factor comes as what here? 2. Valence factor comes as 2. Okay, in this case valence factor is 2. Right. Then we can consider equivalent weight of NaCl is 58 by valence factor. Valence factor of NaCl is 1. NaCl. Okay. Next, other compounds we are going to discuss here. Equivalent weight for oxidizing agents. We have the previous. Okay, oxidizing agents going to discuss here. Oxidizing agents, what here? K2Cr2O21, NH4NO3, AlC2O, Mg2CO, MgC2O4. This case, how can you take? Means here only I am giving basic. I means you need to learn more information about this. How to find only I am going to discuss. Here in acidic medium, so for these all cases, KMnO4 26 by 7, NH4NO3 80 by 1 means here valence factor is 1. Here 6 valence factor molecular weight. Here 2 valence factor 12. So how can you find this? So for this KMnO4 acidic medium changes to Mn plus 2. Then find the oxidation state. It is one process. You will learn in the redox reactions. If you are already know, then okay, easy. Then x equal to what here? Means 1 plus x plus 4 into minus 2 equal to 0, and x equal to plus 7. And already charge is 2, so 2. Then change in oxidation number 5. So molecular weight by 5 is right here. This is what? Change in oxidation state. This comes as valence effect. For this also same. K2Cr2O7 Cr plus, then it is what here? Plus 6. Then this case 2 plus 2x plus 7 into minus 2, that implies x equal to what here? X equal to plus 6. Here Cr is the plus 3, but here 2. So for 2 is the 6. Okay, 1 is what here? 2 Cr plus 6 changes to 2 Cr plus 3. Here what? 12. Here what? 6. Then change is what? No change you can take as 6. So valence factor is what now? Valence factor comes as 6. Sorry, valence factor plus, for 1 Cr is plus 6, 1 Cr is plus 3. So change in electrons, how many you got? For 1, 3. So valence factor is 3 only. Okay. Next is equivalent weight of atomic weight. Calculation of atomic weight. Calculation of atomic weight based on equivalent weight. Okay. That case 1. Case 1 question equivalent weight of Al is 9 and valency factor is 3, then calculate its atomic weight. Then 9 equal to atomic weight by 3, then atomic weight equal to 9 into 3, so 27. Next, equivalent weight of Ca is 20 and valency factor is 2, then calculate its atomic weight. Okay, now here 20 equal to atomic weight by 2, then atomic weight equal to 40. Case 2, atomic weight into specific heat equal to 6.4 calories per gram. Now atomic weight equal to 6.4 by specific heat. Okay, then 1 calorie equal to 4.18, that is nearly 2 joules. Next is specific heat for substance A is substance A is 0.64 calories per gram. Then calculate its atomic weight. Then calculate its atomic weight. Okay. Now we have a formula: atomic weight equal to 6.4 by specific heat. So 6.4 by specific heat 0.64 is given, that is equal to 10 grams is the atomic weight. Next, atomic weight of substance A is 100 grams, calculate specific heat. Atomic weight of substance A is 100 grams. Then calculate its specific heat. Calculate its specific heat in calories per gram. Okay, that implies 100 equal to 6.4 by x, then x equal to 6.4 by 100, that's equal to 0.064 calories per gram. Then suppose question 2 related. If 2.7 grams of Al number of moles is 0.1, calculate atomic weight. 2.7 grams of A number of moles equal to 0.1 mole. Calculate atomic weight. Now moles formula, weight by molecular weight or atomic weight. So consider here molecular weight. So weight is given 2.7, moles is 0.1. Okay. Atomic weight. That implies atomic weight equal to 2.7 by 0.1, 27. So it is simple concept. Now I am going to discuss the next concept, very important, average atomic weight. Case comes as for this one. This is what known average atomic weight. Now in this case, average atomic weight equal to atomic weight of first isotope H plus atomic weight of second isotope 100 minus H comes here by 100. Okay, I will give the example page, you will get the idea. See, I'll give an example. Calculate average atomic weight of iron. Calculate average atomic weight of iron. One of the isotope is 30%. Okay, that implies atomic weight of iron equal to, suppose Fe56 is X%, Fe54 is 100 minus X%. So here 56 into 30 plus 100 minus X means 70 into 54 by 100. The simplified value 54.6 grams. So this is average atomic weight. Now I am going to discuss about the other example, average atomic weight of carbon. Average atomic weight of carbon has 12.5 and has isotopes of C12, and C16, C14. Okay, average atomic weight, and average atomic weight equal to what? Atomic weight of first isotope into H plus atomic weight of second isotope into, okay, so atomic weight of first isotope into H plus atomic weight of second isotope into 100 minus, okay, by 100. Then this case 12.5 equal to 12 first isotope into H, then 14 into second isotope H by 100. Then H is what here? H is 75%. Then 100 minus H equal to what? 100 minus 75, that is equal to 25%. Okay. Next topic, we'll discuss about the some other extensions of the equivalent weights. Okay. And the concepts of molarity, normality, related information. Okay. Thank you. Please subscribe, share, like this. Any suggestions you want to give, you can give me. Okay. Right. Thank you.